Okay, so we're gonna do the enthalpy reaction, enthalpy of reactions. So number 9, when 1 mole of calcium phosphate is synthesized, 4132 kilojoules of energy is released as heat. Calcium phosphate, have to write that correctly. Calcium phosphate is that. And we're saying that for each mole of that synthesized, we release, so negative 4132 kilojoules per mole of calcium phosphate. Okay, now it's just asking how much heat is released when only 21 grams of calcium phosphate is synthesized. So we just need to do a little mole road type of calculation here. It's a terrible 3. Where we're going to divide by its molar mass. I get that to be 310.18 to get to moles. And then we can actually just keep on going because we can use this as our conversion factor. So negative 4132 kilojoules, because that is per 1 mole of calcium phosphate. So that'll cancel there, grams cancels there. And so we will be left with just kilojoules round to 2 sig figs, and I get negative 280 kilojoules. Okay, now for number 10, it's a bit trickier. So part A, I trust all of you can do that. I get 4Fe plus 3O2 goes to 2Fe, 2O3. And it says you have to place the energy quantity on the correct side of the equation. So it tells you that it's being released. So we know that it's going to be a product because energy is being released. It's exothermic. So we can put it here as a product in our balanced reaction. But just take note that it's 413 kilojoules per 1 mole of iron. But we don't have 1 mole in our balanced equation. We have 4. So we're going to actually have to multiply that 413 by the coefficient 4 so that it will apply to this balanced chemical equation. I got 1652 kilojoules. Okay, so it's written as a product again because it is being released through this reaction. It is an exothermic process. All right, so part B is we have this standard heat pack produces 25 grams of iron 3 oxide. What mass of solid iron was necessary? And so this is just a simple stoichiometry calculation from long ago. We have 25 grams of the product, Fe2O3, and we're going to try to get that to grams of just iron. So we're going to have to divide by its molar mass. I get 159.7 as its molar mass. And then we'll use the mole ratio to get to moles of iron. So it's 4/2. And then we're going to have to use one more fraction, the molar mass of iron, 55.85, to get to grams of iron, and I get 17.5 grams of iron. Okay, now part C is where we bring in the enthalpy. So it says if we have produced 25.0 grams of iron and it came from 17.5 grams of iron, how much energy will be released? So I'm going to start with 7.5 grams of iron. And the reason here, I mean, you could start with the 25.0 grams of Fe2O3. You would just have to do a little extra step because the 413 kilojoules of heat is in reference or with respect to just iron. So I'm going to put this in moles first of iron so that we can use that conversion factor of 4 413 kilojoules over 1 mole of iron that was given in the problem. You can see moles of iron cancels. This is grams. Grams of iron cancels, and we'll be left with just kilojoules. If you plug that in, round it to 3 sig figs, I get negative 129 kilojoules as our final answer. And that is